Vi har kommit till dagens 2 sista externa talare och det jag nämnde innan pausen var ett fulländat äktenskap. Vi ska kika på grafen och metaller, bättre tillsammans. Med mig har jag till att börja med Jon Wingborg från innovationsprogrammet SIO Grafen. Hej Jon, hör du mig?
Hejsan, jag hör dig.
Välkommen, kul att ha dig med. Har du lyssnat under eftermiddagen?
Jajamensan, jag har lyssnat på det mesta av er i alla fall.
Ja.
Det var väldigt intressanta grejer.
Vad kul. Ja. Men jag ska lämna ord och bild till dig. Varsågod, berätta, vad är det ni gör inom SIO Grafen?
Ja, nu tror jag ni snart ser min presentation här också. Vi är ju liksom Metalliska material en av de 17 strategiska innovationsprogrammen som får stöd här av Vinnova, Energimyndigheten Formas. Och vårt mål är att vi ska göra Sverige till topp 10 i världen på att använda grafen om bara 9 år har vi nu på oss kvar till 2030. Och hur vi gör detta, det är ju genom att arbeta tillsammans med med alla svenska partner. Hittills har det satsats ungefär 240 miljoner inom programmet, varav hälften kommit från bidrag från företagen och hälften i bidrag från forskningsfinansiärerna. Det har varit 130 stycken projekt, så det händer saker runt om i hela Sverige. Och som ni kommer att se senare under både min presentation och Mamouns presentation här, så kommer det hända saker mot metallindustrin. Ska vi ta till nästa bild. Vad vi gör inom programmet är att vi gör färdplaner likt det vi har sett tidigare. Vi gör strategiska projekt för öppna utlysningar där många av de här 150 projekten har varit. Och där finns möjlighet för er, om ni blir sugna på att använda grafen här efteråt, så hör av er eller kolla in Vinnovas hemsida på den utlysning som ligger öppen i dagsläget. Jag själv jobbar för det som vi kallar ekosystem, som jag kommer ge en snabb intro till snart. Men vi gör också omvärldsbevakningar så ni kan få reda på mer om grafen och såklart kommunicera ut detta. Det vi gör inom ekosystemet är att, känner ni som lyssnar här att ni är nyfikna på vad skulle grafen innebära för oss, så kan ni få möjlighet att få ett möte med oss från programkontoret där vi hjälper och coachar er hur ni kommer vidare. Vi upplever samarbete med rätt partner och som ofta säger också att en viktig sak där kan vara att avråda er kanske i vissa fall. Ni tror att grafen ska göra allt för er, men så kommer det kanske inte vara. Men där kommer Mamoun ge lite mer exempel på var det finns fördelar. Men det är lätt att tro att det här fantastiska materialet ska göra allt, och mycket kommer att göra. Men det gäller att prioritera rätt saker. Jag ska nu gå in på några exempel på vad grafen gör för metallindustrin eller för er som kan lyssna. Mer noggrant av detta kommer Mamoun prata om senare, men här kommer 4 projektexempel. Det första är ett projekt som SSAB har om korrosionsskydd av varmförskiktat stål, där man blandat i grafen. Sedan har vi ett liknande projekt här som bolaget Provexa driver. De har haft ett som är avslutat där de har tagit fram en ytbehandling med grafen. Och denna ytbehandlingen kör de på Lego i dagsläget, så det är faktiskt så långt framme att det går att beställa lackerade ståldetaljer med ett ytskydd med grafen. Den stora fördelen där, förutom korrosionsskydd, är att vi får en viss ledningsförmåga, vilket gör att vissa korrosionsproblem blir mindre tack vare detta. Liknande, men här är det mer med en nötning som bolaget Applied Nanosurfaces driver, som har tagit fram en ytbeläggning. Och det sista projektförslaget kommer Mamoun gå djupare in på, så jag vill bara visa det här. Men det är alltså att blanda in det i metallpulver för 3D-printing. Så det spännande vi hörde nyss kan bli ännu mer spännande med kombinationen av material. tycker ni att det här låter intressant? Att det både jag och Mamoun pratar om idag, så kommer vi ha en mer längre workshop den 4 maj tillsammans med Metalliska material, där vi kommer gå in på dessa områdena lite närmare. Så det var allt för mig. Här har ni mina kontaktuppgifter om ni skulle vilja höra av er, och vi hjälper er gärna att komma igång. Så tveka inte att höra av er till oss på programkontoret. Vi finns här för er skull, och enda sättet vi gör Grafen och Sverige till topp 10 i världen 2030 är det att jobba tillsammans.
Jättefint. Stort tack Jon, det låter jättespännande, och 4 maj så ska vi sätta in i våra kalendrar.
Jajamensan.
Bra. Jon, du stannar kvar. Vi ska övergå till att prata
Jajamensan.
engelska, men du är kvar när vi ska ha en liten frågestund.
Ja.
Mamoun Taher, you are the CEO and Technical Director at Graphmatech. Is that right?
Yes, absolutely.
Welcome, Mamoun. So tell me, what is the link between SIO Grafen and Graphmatech?
So Graphmatech is a small startup company founded as a spin-out from Uppsala University, and SIO Grafen is the important part of the ecosystem to take innovations and to put all the puzzle pieces together and to make them, to collaborate, and of course, as Jon presented, to have a great output out of that. Output can be like innovation, products, and of course, with a target to make Sweden top 10 in 2030. So I am a little more ambitious here, and I believe we can reach this even before. So let's see.
That sounds wonderful. So please, Mamoun, the digital floor is yours.
Thank you very much. It's a pleasure to be here. Let me share my screen.
And while Mamoun is doing that, I will remind you that please ask your questions in the Menti app, and we'll have a short Q&A session after Mamoun's presentation. Also questions for SIO Grafen for Jon. There we go.
So do you see my presentation in the right
Yes.
presentation mode? Okay, great. Thank you very much for the great introduction. It's a pleasure to be here. As I was introduced, my name is Mamoun, and I am founder and CEO at Graphmatech. So the content of my presentation, it will be a short introduction, and then I will take the opportunity to select one global challenge we are living today, and I want to make the awareness. So what is a graphene? I will tell as much as I know, and then metals and the graphene, how can we combine those two to get the best out of their properties? And then I will present selected cases, and of course I will end my presentation by telling the industrial potential and the metal graphene composites, and of course with a short summary. A little about myself. I have background in material science technology with a combination with entrepreneurship. So I have been doing my master's in advanced material science in Germany and Sweden. I got my PhD at Luleå University up in the north in chemical engineering, or surface chemistry to be specific. I was doing my postdoctorate at Uppsala and ABB between 2015 and 17, and there magic happened. So there I started to be at the interface between the industry and research, and I have been involved in graphene related projects, specifically in metals. It was electrical contacts with ABB at that time. So there I started to realize the challenges of a graphene and the possibilities to commercialize a graphene. In 2017, I founded Graphmatech, and then I decided to go more than 100% with all the efforts I can to take graphene to the next level and to make an impact. So a little about Graphmatech. We are based in Uppsala, as I said, a spin-out from Uppsala, from Ångström Laboratoriet. So we work with 3 main business areas. It's polymer composites, metal composites, and additives for energy storage. Of course, the focus today will be on the green category, which is metal composites. So there where we, as you can see in the picture, we are quite central in Uppsala, where we have our offices, our research laboratory, and our pilot line where we can produce between 2 to 10 ton already today. So, you know, electrification, it's happening now, and it's really going to be the future. However, we have a big challenge related to materials. In electrification, we need a lot of copper. For example, in every battery-driven electrical vehicle, so there is between 80 to 120 kilograms of copper needed. for connections, for electrical motors, as bus bars between batteries, for cooling, like heat sinks, and in the charging stations. So the challenge with copper, so the price has been increasing in the recent years. And according to a recent report by the Financial Times, the price only in 2020 has increased by 25%, and it keeps increasing. And why is this? Basically, the demand is keep increasing. So the forecasted volumes for copper for electrification, it's around 800,000 tons by 2025. So the problem is, so the world capacity to produce copper is quite limited. And in order to get new copper mines, absolutely, it's not the case. It will be not the best sustainability solution. And it takes time to get all the permits to operate in new copper mines. If you can see here, so the red, dark red is what presenting the gap we will have between the supply today and the demand up to 2030. So the challenge is already now, it's happening now. So copper must be improved in order to use less copper in industrialization or in electrification, or it should be substituted by another metals. And here what we get the closest, maybe the aluminum. However, aluminum is not that great in terms of conductivity compared to copper. So that's why, okay, there are some technical aspects to be considered. So it's not only us who's saying this, okay? That's a lot of global leaders. They are signaling the same thing, that copper must be substituted by resource saving and electrical conductor material. And here graphene is extremely a good fit to be a part of this, of the solution. So, and here what we are doing at the Graphmatech, we are focused on developing the solution to address this global challenge based on the graphene technology. So graphene, as you know, it's a carbon material, is 1 atom thick. The thickness of basically graphene is the thickness of the carbon atom. And it's a material that has received Nobel Prize in physics in 2010. And it has a lot of very interesting properties. For example, it's lightweight, it's strong, it claimed to be stronger than steel, but in conductivity, it's really more conductive than copper, and by around 60%. Graphene is made in different ways, but let's assume, okay, the most common way is from a graphite. And the graphite is what we use in our pencil tips to write. And the graphite is a mineral used in many industries for decades, or I mean, for extremely long time, for like battery additives or for the metallurgical industry. So graphite is not as great as graphene in terms of engineering properties. So in order to make a graphene, as I said, there are different ways, as I will come to that later. But the graphite is like too many layers stacking together, and you have like peel off every layer to make a graphene. And in order to do that, you have to expand between these layers. And then at the end, you get these nice flakes, very thin, very flexible, and very great in properties, conductivity, mechanical strengths, and etc. So if we, I mean, to simplify it, okay, graphite is like a book. It's thousands or millions of pages are glued together, and the graphene is single page or few pages of that book. And then there are different ways to make a graphene. And then the challenge today, when we say graphene, it's not a standard material. It's a family of different things. It's extremely crucial to know what we are talking about. So for example, there's like a pristine graphene, which is the perfect defects-free bilayer, few layers, multi-layers, graphene oxide, reduced graphene oxide, functionalized graphene, you name it. So that's why these materials, they are different in properties. And if we take, for example, steel, when we say steel, what is steel, okay? It can be 304, 316L, high speed, whatever. The same applies here for graphene. It's a family of different things, and we have to know what we are talking about. It can be, as I said, made from graphite through exfoliation, or something called bottom-up to build like atom by atom on a substrate, and this is what is called chemical vapor deposition, CVD, graphene, which is usually done on substrate like copper at under high temperatures. So now if we come to the point, graphene and metals. So graphene is a carbon material. It's 2D, it's very thin, flexible, mechanically strong, and a metal. Here a metal, I don't want to go specific now, just say a metal. So when we mix these two materials, if you get really nice dispersion, what you get is a composite. there is a possibility that the graphene will chemically react with the metal matrix, and then what you get is like an alloy, or you get, but however, I mean, there's degradation of a graphene happening if it chemically reacts with the metallic matrix. So let's assume that the graphene is not interacting chemically, it's distributed, and then we are getting a nice composite. We call it metal graphene composite, okay? Here we have different things to take into account when we are designing or making this material. For example, what a graphene grade, as I just presented. How is the dispersion of this additive inside the matrix? How is the relationship, the interaction between graphene and the metal matrix? How is the orientation of the flakes? Because in some applications, the orientation is extremely important. For example, heat dissipation. Graphene is really great in a plane, for example, and if you have few layers, it's less great in, thermal heat dissipation. And then, of course, the processing method. How this composite will be later processed by the industry. Are we going to reinvent the implementation method, or we are using the existing processing technology the industry already invested in? So, of course, in the ideal scenario, you have a matrix, you have nicely distributed additive, you have isotropic material. Wow, that's fantastic. And then there you start to get very good properties based on the graphene addition. However, the reality, as you know, in many cases, it's never the case. You get these additives to agglomerate and to stack together. And then you have a lot of free matrix where you don't have access to graphene. And then, okay, it's just like a metal. It's not reinforced, basically. So, and there's another challenge, which is the difference in density between the metal and the graphene. If you are doing melting, so graphene low density will drive it to float on the surface of the higher density material, which is here is the metal. So these kind of things, they are extremely important to think how to design the material, how to make the implementation in order to get the best out of a graphene in the metal matrix. So at Graphmatech, we have been a little innovative here. So we patented a technology, how we can take metal powder and then we coat every individual grain with a graphene. So by doing this, so we make sure that every single grain of metal is getting the needed graphene in order to get the nice dispersion and of course other properties. So after that, what you do is to take the next step. It can be like injection molding, or it can 3D printing, or extrusion, you name it, or different metallic processing steps. So by doing this, so we have been like getting the absolute best dispersion, because we guarantee that every individual grain has access to graphene in the way we want, and the concentration and the thickness we can control. And then we, of course, we can make it cost effective. Then we use the minimum possible for getting the anticipated effect. And by doing this, of course, we can improve the other characteristics of the powder. Because when you put a very thin, like, okay, here I'm talking about extremely, like sometimes less than nanometers of the carbon layer on the surface of the metal, of course, you are changing the characteristics of the metal powder. And here, let me show you, okay, to take you a journey between the microscope of one of the alloys. I believe this was aluminum-based, where we coated every individual grain by graphene. And here, I want you to believe me that every single grain has a very thin layer of graphene on the surface. And if we zoom in, things like looking like this, you have these nice flakes, as you can see, here, here, and there you are getting the graphene on the surface. However, this process is super exciting, but it's also challenging, because if you mess up with any factor, you might oxidize the metal. You know, metal powder, they are quite sensitive for oxidation. And then, okay, and you try to improve something by graphene technology, but you create a trouble somewhere else, which is like a byproduct of oxidation. So these micrographs are taken by our PhD student at Uppsala University, Simon Thedin. So as I will present later, results also generated by him. So when we say, okay, what we can improve by graphene technology, here I will divide it into different levels to make it clear. So the first level is the processing. So I believe graphene technology has a potential to make a huge impact on the carbon dioxide emission by the metal industry. And why is this? Because we can make metals stronger, lighter weight. So then we don't need that much metal for certain application. So then we are saving on the carbon dioxide emission. And of course, we are supporting the sustainability aspects. So the other thing is the powder characteristics. And here I will show you later examples on flowability, conductivity, and reflectivity, and sometimes maybe preventing oxidation for the metal powder by protecting them with a graphene layer. So the other thing is the improvement at the component level. And there, graphene should survive all the processing and stay in the material as additive and deliver a functionality. It can be like mechanical strengths, or conductivity, or corrosion, or tribology, whatever. I mean, it should be at the component level. But in order to get that, graphene must survive the processing of the metal. And we should not forget innovation. Sorry to say that, but metal industry is quite traditional, okay? And it's getting really commodity, and we have the potential here to boost the metal industry again. And of course, we are shifting to a new era of electrification, digitalization, and all these kind of things. So that's why we have to keep developing the metal industry and take it to the next level. And of course, we need new metallic materials for that. So the other one is it's rebranding of the metal industry. So when you say metal industry, I'm afraid, okay, that in the coming years, it will be a challenge to attract talents to work for the metal industry. That's why rebranding, innovation, sustainability, all these kind of things should be really taken into account in the metal industry. So let's talk about the flowability and the laser material interaction as two examples of improving the powder characteristics. So while putting graphene on the surface of the particles, we have the possibility to dramatically improve the flowability. You know, when you have two fine metal powder, they have a problem that they stick together and they don't flow. But if you have a graphene acting as a lubricant, so then the problem is solved. And here I will show you, like you see the video here. I mean, this is a coated metal powder with graphene where the flowability has improved up to 61%. So the other case, I will go more into details, is the 3D enabling the 3D printing of copper where reflection is a problem. I mean, you try to melt the copper by laser, but copper is shiny and reflects. So then it's a problem in majority of 3D printing, selected laser melting of copper. So here you can see example for steel coated with the graphene in different concentrations and how the flowability has improved. So when you don't have a graphene, so the flowability is a problem. And why flowability is a problem? Because in some processes like additive manufacturing, you need to build the powder bed. And if the powder doesn't flow, so then you have a trouble there. You can't proceed in processing the material. So by improving the flowability, you enable the processability. And here you can see some examples. For example, in steel, the improvement was 58%. In aluminum, it was 63%. In iron, pure iron without alloying elements, it was 27%. And in aluminum alloy, it was 61%. So these numbers, they are really great. And if they can combine with the effect of a graphene later on at the component level, they are even greater. So the other cases, as I presented, reflectivity, for example, in copper. So copper is extremely interesting material for electrification. And it's used mainly for heat dissipation and for connections and these kind of things. And together with additive manufacturing, you add the freedom in design to make it like even more interesting. However, copper is proven to have a challenge in selected laser melting additive manufacturing technology. Because as I said, it reflects the majority of the laser beam and you need really special machines with high power, green laser and these kind of things. But what if we can make copper to be 3D printable basically on a wider range of selected laser machines? So here to the left, you see the relationship between the graphene concentration in the coated powder with the reflectance as it has been measured in this device. And this is still under publishing work together with our collaborator at Uppsala University. So there you can see that the graphene has dramatically improved the absorption of laser of copper powder. So the improvement was at the level of 67% at the highest concentration of graphene. However, highest concentration of graphene is not always the optimum. So here you have to find the balance between the improved absorption of laser and between the properties or the added value from the graphene coating. So here you can see optical microscopes and scanning electron microscopy of the pure copper reference and the coated copper with graphene. And what we have observed that the density of the coated copper with graphene has been much better than the density than the pure copper. And there, okay, that's extremely good indication. And what was even more interesting, so that the graphene has survived the 3D printing. So we could detect, as you can see here, like sheet-like structure to the material, which is, I mean, similar to the starting graphene material and the coating process. So this is super interesting because we already improved the processability of copper, but there is also a strong indication that the graphene has survived to further improve the characteristics of the component. So here the improvement is at two levels. It's at the powder and at the component, and this combination is what makes the business case very interesting. So you might ask, can graphene improve the copper properties? So here I don't tell much, but I can tell you in general, yes. And in another project where I am not able to talk that much, so we measured improvement in the copper when we added low concentration of graphene. Improvement has been even at the thermal and electrical conductivities. So with this, I mean, there is a huge potential that yes, we can make copper even greater to enable the use of much less copper and to duplicate this work on other metals to make them, I mean, even to exceed copper in properties and to replace it in the future. So additive manufacturing was one thing, but we have also proven that we can manufacture metal graphene composites in the conventional ways. Today, like extrusion, for example. In this specific case, it's silver graphene composite, which is used for electrical contacts. It can be for sliding contacts or for arcing contacts and switches. And here together with industrial partner, so we produce this material at, the full industrial scale. As you can see here, you produce pellets between 20 to 40 kilos. You do pre-sintering and you do the extrusion, and what you get at the end is like a stripe of the composite. So a common question we get from different industries: would graphene survive the tough conditions needed for processing metals? In order to answer that question, so I would say this depends on different factors. Of course, there is no clear answer to that. We have to consider the graphene grade used, the chemistry of the matrix, the relationship between them, and of course the processing parameters. However, what I can tell you that we have proven, at least in 3 cases, that graphene has survived, for example, the sintering of ceramics, and this was 1800 Celsius degrees, survived the 3D printing of steel and copper, and the extrusion of both silver and aluminum. So with the data we have in hand, yes, we can tell that yes, graphene can survive the processing of the metals and make metal graphene composites. So here I also take the opportunity to highlight a few projects financed by SIO Grafen. So when I got the question before I started my presentation, what does SIO Grafen is doing for that? They are the extremely important part of the ecosystem to make these consortium to work together and to get the best innovation output. So through SIO Grafen, we got, so far we have 3 financed projects with different Swedish industries and research institutes. For example, the one here to the left is for additive manufacturing for components reinforced with graphene. This was with Sverem, with Sandvik, with Uppsala University, and the Quintus. The other project which we got continuation just recently is steel and additive manufacturing. So in the first phase, we got really interesting results. We could 3D print the coated steel powder with the graphene. And we got indications that the graphene kind of survived the selected laser melting processing and improved the tribological properties. So now we get larger project, and together with the same consortium, so we are going to make further investigations, and of course to, at the end, see the commercialization aspect of this technology. So we are also a member of the Graphene Flagship, which is the largest ever EU initiative for graphene technology. So there we are doing very big metal project together with ABB and different industrial partners in different countries. We have Chalmers and Manchester University with us as academic partners. And there we are also making metal graphene composites for electrification related applications. So here I take the opportunity to thank all the industrial and academic partners we have been working with. So this what we believe is extremely important to take the innovation to the next level and to have a leading position in not only in Sweden, but globally. So to summarize what I have been saying, that graphene technology really offers a solution for the electrification challenges I started my presentation with. The copper challenge, but of course to improve the characteristics of other metals and open new business opportunities for them. So there is a potential, but this potential must be further explored. So, and as I said, the improvement, it can be at the powder and the processing level and at the component level. And then we have to consider both when we are designing or when we are thinking about the graphene technology. So we should not forget the innovation aspect of a graphene. As it is a new material, it really allows us to think out of the box and make new combinations, new material design, which was not possible before. So, and here we have to take the opportunity to look beyond what we are capable to do today, because we have the technology, and if we implement in the right way, so we believe the future, has limitless possibilities. So in order to keep, I believe, and when it comes to metal graphene technology in Sweden, I would say a little bold here. We already have a leading position, but in order to maintain this and to make it even stronger, so I think we have to continue to build the knowledge. So the knowledge comes from collaboration between academia and industry. And we have all the components needed in place. We have the best research institutes in metals, best universities, best researchers. We have startups, we have large metal industries. So we have everyone in place, and we have SIO Grafen to moderate this ecosystem and make it to happen. So of course we have to continue to collaborate, because collaboration is what will take this to the next level and to maintain the leadership position we have. And of course to build a strong consortium where we have to involve academicians, industrial leaders, and politicians, because I believe the future is just a huge possibility with this new technology. So if you have any question related to metals and the graphene, and if you wonder how graphene technology can benefit your project or your business, so we will be happy to take a dialogue with you. And if you have any further questions, so please, you can reach out to me. So either here in the chat, or absolutely you can drop me an email, and I will be happy to help you. Thank you very much.
Thank you, Mamoun, and thank you for that invitation. Now people are watching at YouTube, so reach out to Jon or Mamoun if you have any more questions on graphene. And we got some good questions here in the Menti app. So we're a little short on time, but I think we're going to use some extra for this, because I think it's very important to follow up. So this one question, you mentioned innovation, Mamoun, the need for more innovation. So from your point of view, what can we do to boost innovation in metals, in graphene?
So we have to ask to answer this, I think we have to answer where innovation happens, where it happens usually. It happens at the intersections, okay? When people from different backgrounds and different, from industry and from academia, they start to discuss and meet. There where innovation happens, okay? And of course, to take that to the next level, so you need a complete ecosystem. And that is what is, we have, as I said, everything in place. We have the world best researchers, research institutes, world leading industries. We have initiatives like Vinnova, SIO Grafen. So what we need is just the great communication and connections between these components.
Yeah, wonderful. So, and do you see any challenges? We got a question here. What are the greatest challenges for graphene?
So the greatest challenge, I mean, there are, of course, any new technology is surrounded by different challenges. So standardization. So this is one of the challenges in order to take something from the innovation level to the commercialization level, you need standards. And this is what I believe we are working quite good on that here in Sweden. You need also to accelerate the innovations, you have the speed. So big industries, the metal industries, they are fantastic, but speed difference between them and entrepreneurial driven startups. So that gap in speed is a big problem, because for a startup company to wait for a prototype for 24 months, we can't afford this. We need speed to be at our level in order to progress.
Yeah, I'm gonna pick another one here. What about recycling when you mix metal and graphene?
Yeah. So this to be further investigated, but what you get, you melt them, and then on the top you will get the carbon material. Then it will be a question, is it still in the form of graphene, or it has degraded into another type of carbon? So it depends on different factors. As I presented for the survival of graphene, it depends how you are doing the recycling. But it's a carbon material at the end.
Yeah. So we have time for two more questions. This last one is for you. Oh, this is your last one, Mamoun. If you could dream big, what is your dream application for graphene together with metallic materials?
So my dream application, I would like to see every single electrical vehicle rolling in the roads everywhere in the globe containing a metallic graphene composite manufactured in Uppsala by Graphmatech.
Sounds like a good wish. And Jon, one last question to you. The goal is 2030. Can you tell us a little bit more about that? What are you going to do next to meet this goal?
What we do is that building this collaboration between the industry and the academies, like Mamoun said. So what we try is to get everybody on board to make the best projects, and we need to work together, as Mamoun said, at success with this. So it's not one person that will solve this. It's Sweden, and we are great in metal industry, and we will be great in graphene. So it will be a great combination.
We are gonna follow the graphene in Sweden, and it sounds like Sweden is on a good way to reach this goal in 2030. I want to thank you both for joining us today. Thank you for a great presentation, Mamoun and Jon. I'm sure these two innovation programs are going to have a lot to do with each other in the future too. May 4th, was that the date for the next seminar? Yeah.
Yeah, exactly.
Yeah. Wonderful. Thank you for joining us today.
Yeah, absolutely. Tusen tack. Thank you very much. Bye-bye.